Picture this. You're at a convenience store on a hot summer day. You're thirsty, desperately thirsty, and you're staring at the drink cooler. There's your favorite soda, same brand, same flavor, same price. But you have three choices: a plastic bottle, a glass bottle, or an aluminum can. Without thinking, you reach for the can. Why? Because somehow deep down, you know it tastes better. Crisper, colder, more satisfying. But then your logical brain kicks in. It's the same liquid, the same recipe, the same CO2 bubbles. How could the container possibly change the taste? Well, here's the truth. It's not your imagination. Soda genuinely does taste different depending on what it's packaged in. And the reasons why reveal a fascinating war between chemistry, psychology, and corporate cost-cutting that's been quietly brewing inside every beverage aisle for decades. Today, we're uncovering why soda tastes better from a can, right here in Humos. Let's start at the very beginning. For most of history, soda only came in one container: glass. In the late 1800s and early 1900s, Coca-Cola, Pepsi, and every other soda company used thick glass bottles. Glass is chemically inert. It doesn't react with the liquid inside. It doesn't absorb flavors. It doesn't release chemicals. It's the gold standard for preserving taste. If you've ever had a Mexican Coke in a glass bottle, you know exactly what we're talking about. It tastes sharper, cleaner, more authentic. But glass had problems. It was heavy, expensive to ship, and it shattered easily. In the 1970s, the industry faced a crisis. Fuel prices were skyrocketing, and transporting tons of heavy glass across the country was bleeding money. The industry needed a cheaper, lighter alternative. Enter plastic. Specifically, PET plastic, polyethylene terephthalate. It was a miracle material, lightweight, shatterproof, and moldable into any size. By the 1990s, plastic bottles dominated the market, but there was a hidden cost: taste. Here's the problem with plastic. Unlike glass, plastic is porous on a microscopic level. Imagine the walls of the bottle like a sponge, not a solid barrier. This means two things can happen. First, CO2, the gas that makes soda fizzy, can slowly escape through the plastic walls. Even if the bottle is sealed, over time, the carbonation leaks out. You open a plastic bottle of Coke that's been sitting on a shelf for a few months, and it tastes flat, dull, lifeless. Second, plastic absorbs flavors and releases them back. If your plastic bottle sits in a warm warehouse next to boxes of detergent or near strong-smelling chemicals, those odors can actually permeate through the plastic and taint the soda inside. You might not consciously taste it, but your brain picks up on something off, something slightly stale. Then there's the chemical factor. PET plastic contains a compound called acetaldehyde. In tiny amounts, it's mostly harmless, but it definitely has a noticeable taste. Some people say it's faintly fruity, others say it feels a bit plastic or synthetic. When soda sits inside a plastic bottle for too long, especially in heat, small traces of acetaldehyde can slowly seep into the drink. It's subtle, sure, but your taste buds can still pick it up. That's why a plastic bottle of Sprite left in a hot car tastes off. It's not just warm, the chemistry has actually changed. This is why a can of Coke from the back of your fridge tastes exactly the same as a can that just rolled off the factory line. But here's where it gets even more interesting. Aluminum itself would be a problem. If soda touched raw aluminum, it would react chemically, giving the drink a metallic taste and corroding the can from the inside. So engineers coat the inside of every aluminum can with a thin layer of polymer lining, usually a type of epoxy resin. This lining is only a few microns thick, thinner than a human hair, but it creates a perfect barrier. The soda never actually touches the metal. It's chemically protected, carbonation locked in, flavor preserved. There's also the temperature factor. Aluminum conducts heat much faster than plastic or glass. This means when you put a can in the fridge or an ice bucket, it chills almost instantly. Cold temperature does two things to soda. First, it makes carbonation feel sharper and more intense. CO2 dissolves better in cold liquid, so a cold soda feels fizzier on your tongue. Second, cold numbs your taste buds slightly, which actually enhances certain flavors while masking others. It reduces the perception of excessive sweetness and amplifies the crisp, refreshing sensation. A plastic bottle, because it's a better insulator, takes longer to chill and warms up faster in your hand. By the time you're halfway through the bottle, it's already lukewarm and flat. But wait, there's more. Psychology plays a massive role here. The experience of drinking from a can is fundamentally different from drinking from a bottle. When you crack open a can, you hear that iconic psh sound, the violent release of pressurized CO2. That sound is burned into your brain from decades of advertising and cultural conditioning. It signals freshness, coldness, satisfaction. When you drink from a can, the opening is smaller and the liquid hits your mouth faster, delivering a more concentrated burst of flavor. Compare that to drinking from a wide-mouth plastic bottle where the liquid kind of sloshes into your mouth in a less controlled way. Then there's the ritual. The pull tab, the metallic clink when you set it down, even the slight coldness of the aluminum against your lips. These sensory details are part of the experience. Your brain associates them with refreshment. Studies have shown that people rate the exact same liquid as tasting better when it's served in packaging they perceive as premium or authentic. It's called the expectation effect, and it's incredibly powerful. Finally, let's address glass one more time. Glass is still the king of taste preservation. Mexican Coke, craft sodas, fancy tonics, they almost always come in glass because serious beverage makers know it's superior. Glass doesn't affect carbonation, doesn't leach chemicals, and doesn't absorb odors. But glass is expensive and fragile. For mass market sodas, it's just not practical. So the can has become the best compromise, better than plastic, cheaper than glass, and engineered to near perfection. Here's something most people don't know. The soda companies themselves know all of this. They've done blind taste tests. They know that Coke from a can scores higher than Coke from a plastic bottle in consumer preference studies. But they can't abandon plastic. Plastic bottles are too profitable. They're cheap to produce, easy to transport, and customers love the resealable cap. So the industry keeps both formats alive, letting you choose between convenience and taste. So the next time you reach for a can of soda, know that you're not being irrational. You're responding to real chemistry, real physics, and a century of material science innovation. That aluminum can is a tiny engineering marvel, a perfectly sealed, light-blocking, cold-conducting vessel designed to deliver your drink exactly as the formula intended. The can doesn't just hold the soda, it protects it, preserves it, and yes, makes it taste better.